So this session is about making utilities smart. As such, I'll be focusing on Ribbon's solutions for oil, gas, water, and energy. They are all have similar traits with some subtle differences. I won't be focusing on any of the other critical infrastructure type solutions like for rail and highways. That will be another session in the future. My name's David Stokes. I'm head of IP portfolio and IP solutions marketing. And my colleague Jonathan Homer is also on the call, who is head of our optical equivalent. So we work in tandem, but this will mainly be focused on me because I believe that's the value proposition. Primarily, we enter utilities with, and then we increase that value by bringing the optical story to really give our partners a great set of portfolio and solutions to position into their customers. So why do I say that this market's important? Well, firstly, there's a huge amount of total addressable market in EMEA. This is based on figures from Signal AI with some sort of analysis of those based on Ribbon's understanding. So the TAM for telecoms in these markets, is about $1/3 billion, give or take, of which it's probably split 2/3 for the IP aggregation part and 1/3 for the DWDM part. And the reason for that will become apparent as we move through the deck. The other reason this represents a huge opportunity is not just the addressable market. There has to be a tipping point or a reason for utilities to want to change. Can you go on mute, please? To want to change. And as we will see through the deck that the utilities have to modernize. They are moving more and more to need to become smart for various reasons. Regulation, need to meet their carbon goals. They're all moving to a decentralized model. In short, they're all looking to become smart. That means putting more monitors out there, and those these days tend to be either digital, based on packet-based technologies, and the legacy communications network really isn't suitable for doing that. So there's actually a real reason why utilities need to modernize. It's just not just because 5 years have gone by. In reality, 25 years have gone by. And telecoms is in the heart of this modernization. If you put all these sensors out there in the network, clearly you need to collect all that data back and bring it back to command and control centers. That can only be done by telecoms. And then a little bit further in the future, and depending on the regulation in each country, that once they've got that infrastructure invested in, a lot of utilities are looking to become UTelco, offering a range of different services to other service providers, even to end customers as residential broadband. And we've at Ribbon, we've built an IP solution, our IP optical middle mile, that's absolutely optimized for the utility needs. We've had 30 plus years experience in utilities. We know what they require in their networks, the longevity of the equipment that needs to go in there, the resilience and availability needs. In fact, what their DNA is, what really motivates them and what doesn't. And we can share that with you. Of course, those of you who are experienced in utilities will talk with us, and we'll fully understand each other, talking as people who are working into utilities together. So I'll hope to show you over the next half an hour or so how our Ribbon's IP optical middle mile for utility is actually optimized for this modernization. And we'll talk about some of the proven technology that we have with our partners and the customers. So what sort of issues are facing utilities? This is a survey done by Black & Veatch in the US, but the challenges are on the power sector, but the challenges are pretty much the same. They've got a aging infrastructure. They've got a lot of decentralized resources, whether that be renewables in the power industry, whether that be flow monitors and gas and water and oil pipelines. They've got the infrastructure is aging and aging quite badly and needs modernization. And as I said at the start, this needs a modern communications network to replace the legacy SDH network. Also, the workforce in the telecoms area of these businesses is aging. They really, those guys who understood SDH have either all retired already, are about to retire, or are back on retention as consultants. So you don't really want to rely on this. So you need to move to a technology that you can get younger people out of university that they actually understand. And that isn't SDH. That's actually Packet. And then as we move into a more distributed network, security becomes a key concern. And you need to be able to select these utility customers need to be able to select from a best-in-class cyber ecosystem, choosing the right components that meet their security guidelines put in place. So whether that be a SCADA anomaly detector from Palo Alto or an IPS from Fortinet, they will have their own security guidelines, and whatever solution we put in telecoms has to be able to work into the SEMs, the IPSs, the IDSs that they're using. So it has to be tooled and geared so it can provide those systems with the right touch points. And of course, as we'll go on to see, our ribbon solutions provide the right tool set to achieve this. So as I mentioned, telecoms is the foundation or the heart of this smart utility evolution. We often hear in the power sector the term the 3Ds: digitalization, decentralization, and decarbonization. These also apply to oil, gas, water for the same reason. You're digitizing to get more information back from the network. That information is taken, what used to be everything centralized. Now you have AMIs in customer premises measuring consumption. You're decentralizing there. Obviously, in the energy industry, you're having distributed renewables, decentralized in there. And there's a massive pressure, regulatory, to both decarbonize in terms of using power, but in terms of, say, the water industry, to stop leakage and to massively reduce the leakage in some very, very ancient pipelines. And that requires all the flow control monitors to allow you to detect where the leaks may occur before they become too severe. So all of this is forcing those utilities to become smart. What does that actually mean? Well, that actually means that they need to deploy a whole bunch of new industrial IoT devices to monitor what's going on. They're also, for security reasons and perimeter security, put on a whole bunch of CCTV cameras in, particularly in the energy industry, around substations, a remote plant, put in CCTV to give perimeter security. So the field area network is massively evolving from a very limited, just keep the thing working type field area network to one that can actually provide real valuable information and data flow back to the command and control centers, which are now deploying things like machine learning. In the future, I suspect they'll use AI to try and interpret that data that's coming back from the field and use it to action behaviors on the network that allow them to reach these goals of improving the way the network works. So to achieve this, you've got a vastly increased amount of information coming back from the network. For the command and control to be valuable, much of that information needs to be transported in real time, so you can actually take action when's required rather than 3 hours later. And as I mentioned, the only way that can be achieved is by modernizing their communications network. The SDH network really isn't geared to support the volume of data that's now going to be generated. And it's certainly not architected to support the amount of data that is packet based. In addition, the SDH network itself is end of life. Many manufacturers of SDH equipment have end of lifed it, won't support it anymore, will give extremely expensive service support contracts. So it's really important to get off this legacy SDH network into a new packet network that can take those utilities forward for another 10, 20, 30 years. And I mean that, the SDH network, we have equipment, SDH equipment that's been in the network for 25 years. So do GE, so do Marconi or Ericsson. So there's lots of stuff that is out there 25 years. This is the sort of lifetime people expect telecoms equipment to go into the network for. However, these SDH services and devices that are currently in the network are not going away anytime soon. I would be surprised if I was not saying the same thing in 5-10 years time. These devices are not going away soon. So you've got this dichotomy. You've got legacy SDH services and devices and PCM type equipment, old SCADA, legacy substations, etc., plus the new stuff. So you need a modernized transport network that can support both. And many of the operations technology devices require very deterministic transport information. Deterministic in a way that modern IP/MPLS isn't really geared to do. So you need something slightly different. You need a very deterministic packet transport network able to support both legacy and emerging applications. And with our IP optical technology, we can provide you the ability to give to your customers the confidence that they can put a new packet transport network in place, which has been proven across multiple different customers across the globe. Now, we've dealt with hundreds of customers adding a new packet transport network in and providing them support for both legacy and modern technology. So that's sort of setting the groundwork. What does this modernization look like? So the utility network today, it was based really around rapid recovery in the event of failure, always on fault tolerant network, because clearly it's critical industry, critical infrastructure. It needs to be always on. Not that it always is, but that's the goal. And there's got to be strict performance constraints on the telecoms network. Now we see that those elements still stay valid, but we add a huge number of extra requirements based around scalability as the operators look to make their network more smart. You've got to get more devices out there doing more stuff, so it needs to be highly scalable, supporting growth of that intelligent network. It's got to be able to support old and new, so you've got seamless support of old and new technology. We mentioned the security, absolutely important. It's got to support that, and then it's got to be able to move forwards with the times. If we're thinking this network at a minimum will be going in for 10 to 15 years, I believe that in those command control centers, everything will be machine learning, if not most of it being AI at that point in the command and control. So you really need to think about what you're putting in now is able to put the communications network in place to support them going forwards over the next 10, 15, 20 years. And then, of course, I mentioned about evolution to UTelco, offering broadband services or wholesaling telecom stuff. Once you've got the network infrastructure in place, that network has to support that. So that's, in a nutshell, a summary of the differences as we move from where we are today in utilities and what the utilities need to get to in the future. And just to give you an example, about the sort of data we are talking about. What in the past used to be a few tens or hundreds of megabits is now in the range of a few terabits of data. If you're thinking in the power industry, you've got all those AMIs, smart meters. Now they're going to generate about 1 terabit of data a day. But then you've got all the feeds from those security cameras I've mentioned. And they are at the moment about 9 gigabits per day per camera. That quickly ramps up. And as you go to more high definition cameras, so you can do facial recognition, etc., to allow facial entry into secure sites, they're going to just go up more and more and more. And then if you think about all those cameras that are going to go around all of those solar farms, I mean, if you've ever been to a solar farm, it is utterly incredible the amount of security that's put there. And that's going to be loads of stuff. So this is going to go up massively. And then, of course, you've got all of this. You've got all of the stuff from the remote sensors, etc. I'm just going to put this gentleman on mute. Sorry about that. So that's where your 6 to 8 terabits per day add up. But you can see that it has the potential to increase massively over time. For this volume of data, you need service awareness, service aggregation from a packet type device, but you're also going to need a bulk optical transport component to your solution. So you'll see that the optical part of the story will become more and more important over time. And then similarly, the same applies in water and gas. You've got smart meters in people's homes, measuring the gas and water consumption. Same story for cameras around their processing plants, their wells, etc. And then you've got all of the SCADA control circuitry as well as that's out there, both legacy SCADA and packetized SCADA. So this is where those huge numbers come from in terms of amount of data. So as these networks modernize, you have this issue that your customers face. As I mentioned, in oil, gas, water, you've got security, digitization, explosion of data. In energy, you've got those, plus you've got this complete decentralization of generation with its own unique problems. Solar farms, wind farms, particularly solar, huge security elements there. And then you've got the ability to use telco. You've also got 2 different bits of their network. You've got the OT network keeping all of their infrastructure working. And then you've got the IT network, which is managing the services and enterprise. And make no mistake, these guys are real enterprises. So they have all the IT stuff that you expect from a modern enterprise. You've got 2 separate networks with 2 totally different sets of requirements. The OT network needs to be able to deliver mission critical services, be incredibly reliable and secure, 5 nines at worst. For things like teleprotection, other control stuff, you need unbelievably low latency and completely deterministic latency. In the IT network, everything is driven by IP/MPLS. So you have this drive for a dynamic IP, which is best effort or best effort within reason, but you certainly can't guarantee against it. But the OT network needs guaranteed performance. So you have this dichotomy of needs driving this evolution of the network. So to sort of convey what we mean by that, so as you can see, the OT applications are all mission critical, and these are things like SCADA, teleprotection, the PMUs, the remote energy resources, all mission critical, and they've got to absolutely have high reliability, high latency. Absolutely not have high latency. Latency is highly important. They have to have very low latency and high security. However, Compared to an IT network, even though I mentioned the security cameras, the actual bit rate per device is very, very, very low. Now, if you think that the bit rate coming back from a flow sensor in a pipe is a few tens of kilobits, maybe megabits. So you've got this, whereas the IT applications will vary depending on what they are, from sort of medium level of bandwidth, reliability, latency, security, through to high. So you can see this split of the two different networks that I mentioned. And the challenge here is to build a communications network, is for you to offer a communications network which can support both needs. I mean, depending on the kind of opportunities you have. I mean, if you're going in and just position OT modernization, then you need a communications network that can handle all of those mission critical type components. If you're looking into IT OT convergence, which we see more and more of, then you need to be able to a communications network that can do both. So at Ribbon, we have a comprehensive portfolio optimized for utilities that you can offer to help meet all of these needs. And we've built this in conjunction between our knowledge of the customers, our feedback from our partners, but what is best and what works the best to actually help you win in the critical infrastructure space. So there are our solution components are really made up of 3 different sets of portfolio. I hesitate to say that because it's actually one integrated solution, but there are 3 distinct bits of functionality within that solution. The first is the packet transport network itself, which everything is predicated on. This packet transport network from Ribbon allows you to offer both dynamic and deterministic packet transport. It can support current and legacy interfaces, uses the right transport protocols across the network to meet the service needs, and then puts that out on the network on the right form of optical transport, whether that be grey optics, coherent optics, or some mix between. And then, as I mentioned, optical has become absolutely key to this solution. And we have our Apollo portfolio, which can take that optical feed, apply DWDM techniques to optimize the wavelength uses and the transport across the network. We can do OTN switching as well to allow you to really aggregate that traffic together. A fully flexible set of network functions from both the packet side and the optical transport side. But none of this really works unless you've got an intelligent control system bringing all your assets together. And that is our Muse automation network control system that monitors the health and security of the network to make sure it is working at an optimal level at all times. When there are failures, it is able to quickly identify the root cause and get maintenance staff out to the right place. But more than that, we have deployed these solutions, as I said, for 30 years, not the one in front of you, but learning every single time we work with a customer. So we've got extremely large expertise and experience and have the processes to work with our partners and our end customers, put these networks in place as they modernize in a way that they feel really confident that they're going to have a network that works for the long term. Give them the confidence to actually migrate their legacy services onto this new network. I've talked to a number of end customers and partners who've told me anecdotally of stories where they've gone for a solution from a different vendor and they've been too scared to migrate their services. They've put the solution in place, probably an IP MPLS solution for their OT, which is never the best recommended solution, and then be too nervous to migrate all of their services onto that network because they're just not confident. With what we have at Ribbon and our proven track record, we can give you that information so that you can migrate that network. With this experience, etc., you can rest assured that we're not just another telecoms vendor who's targeting service provider and going, oh, how can I use my equipment for critical infrastructure? Oh, I'll tweak this and tweak that, and suddenly it's a critical infrastructure solution. That will not work. Critical infrastructure and utilities, transportation, defence are key areas of focus and investment for Ribbon. We invest and focus on our technology, on our processes, on our field support, and working with partners. We'll spend time to work with you to help you position the right solution at the right time to the right customers. It really is of key focus to Ribbon, this critical infrastructure business, and we will continue to push features into critical infrastructures. A great example of this is we're one of the few vendors on the market who supports all the legacy PCM interfaces required for utilities on our modern packet transport networks. We're one of the few vendors of the main packet vendors who strongly advocate MPLS TP for doing packet transport for OT, because we understand the needs, concerns, and fears of our end customers. But if they want to go IP MPLS, we also support that. So we have the ability to help you by giving you a full tool set that you can take into your customers and give them the confidence to move forwards. And of course, that's supported being a global company with offices and technical expertise across the globe. We have local support and expertise to help you migrate your customers to win business, answer RFPs, drive need and opportunity. So in short, with all of that, we're a relatively large vendor, and we have a large vendor capacity in terms of packet transport, optical networking use, but we've got the startup agility needed to really put new features in, particularly around the critical infrastructure space. One example on that, which I don't think I mentioned in the rest of the presentation, is that we've discovered that fiber optics lying in water trenches for long periods of time start to degrade. So we've actually implemented, which will be in the roadmap, not in the roadmap, it'll be released this year, the ability to switch MPLS tunnels based on bit error rate. Easy in SDH, bit error rate's a bit more complicated to work out in a packet network, but we're introducing that feature, and I think we're unique in being able to support that sort of feature where you start to see severely errored seconds or increased bit rate. These are the SDH terms, but basically the transport network's not working as well as it should do. It's not failed, but it's starting to degrade, and we're able to switch over based on that. It's not the sort of thing packet networks normally do, but we have that feature that we are introducing this year. So as I mentioned, we have this full tool set that we can allow you to take to customer, ranging from that deterministic packet transport, the optical network, and Muse truly is a multi-layer network controller, able to look at the network as a set of functional resources and use the right functional resource, whether that be a packet resource or an optical resource, use the right functional resource to give your customers the network they need on a per service basis to meet their performance requirements, and supporting all of the legacy and new devices. And by doing this, not only do you get a network that really meets the performance requirements, because you truly understand what's going on in your network resources and between them, you're also able to deliver this at the lowest TCO because you're utilizing the network to its best mechanisms. So you really actually are driving, not only are you giving best performance, you're giving best TCO. The two go hand in hand if you do it right. And of course, depending on which customer you're going to, they may be deep experts in packet and optical. Great, they can go and handcraft everything. Many are not. So within Muse, we have some really, really powerful workflow engines and automation, allowing you to configure across the network in an automated or semi-automated way. The really, really powerful solution, comprehensive tool set to offer to your customers, and proven across many, many, many deployments. So I'm going to take a sidestep now and talk about some of the key value propositions that you can take to your customer to say why they should select you and why they should select you using Ribbon. So probably one of the most foremost ones when I'm looking at the OT network is that we are strong advocates of MPLS-TP. We support and have supported the standards definitions around MPLS-TP since its inception back in the early 2000s. Why is that? Because we understand critical infrastructure and their needs, basically. And we know that utilities and critical infrastructures need deterministic packet transport. So you started off with IP. Obviously, that was a very difficult technology for a utility to understand. It was very difficult for anyone to build a huge, big network, with every router having to understand every other router. So very rapidly after that, IP/MPLS was deployed into the network. That simplifies some of that communications across the network. These labels you add onto the packet also allow you to add OAM type, limited OAM type capabilities into that packet transport. So IP/MPLS rapidly became the technology of choice for transporting Ethernet services across the network. However, it wasn't really designed to be deterministic. Sure, you had QoS and VLANs, but if you had too many jumbo frames in the high priority queue, all of your lower priority queues would be blown out of the water, and similarly, too many jumbo frames, even mission critical stuff would be blown out of the water. Whilst there's QoS, there is still best effort because it's approximations of what's going there. You certainly couldn't calculate the latency across the network, and they certainly couldn't do bidirectional paths, which is absolutely essential in some of the mission critical services. So shortly after IP/MPLS was invented, MPLS-TP was used, which takes the best bits of IP/MPLS and the best bits of SDH and SONET and brings them together. So eliminating some of the more best effort capable stuff in IP/MPLS and then adding some of the more deterministic bits from SDH. So this MPLS-TP technology, absolutely brilliant for utilities, not so good for dynamic packet transport because you're taking away actually a lot of the control plane and stuff that makes IP a really strong technology, but it's absolutely optimized for mission critical transport. Where the control plane in the network in IP/MPLS determines your label switched path across the network. So the network decides where the network routes. In MPLS-TP, that's all done from central control, from your management system, just like SDH. Because it's done from the management system, you can set bidirectional paths, just like SDH. Because it's done from the central management system, you know within a few microseconds what the latency across the network would be, just like SDH. Because of that, you also, because you can set these paths up and duplicate paths, you can switch very, very rapidly. You certainly can easily meet the 50 millisecond switching time. Depending on how many PDUs you use to make the switch, you can switch within 10 milliseconds very easily as well. Again, just like SDH. So basically, you've got this technology that's optimized for mission critical type service, and it's proven in the network for the last decade or more. The IP/MPLS guys realized that they had a problem, that they couldn't support these sort of services. So they've done various approaches to try and make IP/MPLS more deterministic. They tried with IRS-VPTE, which is absolutely brilliant for very small networks. And if you're an IP engineer, it's complex to administer. it only going to work for very, very small regions. And so they realized that that was an issue. So then more recently, you hear a lot about SRTE. It has potential. It's not going to be as deterministic as MPLS-TP. I yet to see it proven in an OT environment, particularly for teleprotection. I have severe doubts that you'd be confident to move that. And there must be issues with SRTE. Otherwise, Cisco would now not be pushing something called SR circuit style, SRCS, which is now in draft for Cisco. So they've had, on the IP MPLS, so there are multiple attempts to try and make IP MPLS more deterministic. MPLS has been there for more than a decade. So, and it's deployed and used for teleprotection and everything. So you can have the confidence that MPLS-TP is the right approach at this point in time. However, as I said, we support both MPLS-TP and IP MPLS. We support MPLS-TP, but we also support all of the technologies on the right. We don't currently support SRCS, as I say, it's in the standards at the moment. When that becomes standardized, we'll also support that. So rest assured, you can give your customers the confidence that we have a full solution set there. And as I've mentioned, this MPLS-TP gives you that deterministic transport that your customers are used to. It's all does at least as good as SDH, has an SDH look and feel with the OANM required like SDH, with bidirectional paths like SDH. So absolutely gives you the edge when you position your customers. And just the final note on this, a number of our customers, some of them may be even on the call, have tested our IP MPLS for OT services, and they've not been confident in using it. So they've actually are using MPLS-TP for those type solutions. So a small deeper dive into the actual products within our portfolio. MPT is our packet transport IP routing platform. It supports all of the legacy interfaces you need in this network: bidirectional, CODIR, X25, SCADA, FXS, FXO. So all of those technologies you need. It replaces that legacy SDH network, and it also has all of the modern packet transport you need to support all of the modern devices being rolled out to the network. Now, clearly, as the field area network, those IIoT, CCTV networks get rolled out. The sort of access network which is coming in to this telecom network is going to vary from wireless networks, fixed networks. At the service edge, we can support data from all of these various interfaces, whether that be LoRa, 4G, 5G, fiber, etc. So all of the field area networks, we can take that data and transport it across the network, guarantee the performance meets on a service by service basis. We provide deterministic packet transport where required. We provide dynamic packet transport where required. In terms of topologies, of course, it's IP. It can support whatever topologies you need, whether that be chain ring mesh, and whether that be point-to-point, dual-homed, etc. We can support whatever topologies are required, and we have a huge range of form factors, ranging from our smallest box, which is about the size of a pint glass, and can support 32 gig, all the way through to our biggest box, which can support 4.8 terabits throughput. The range of form factors to meet your customers' needs in terms of capacity required. Those form factors also vary between devices which are fully redundant. Everything in them is redundant, giving them the confidence they can put a device out there in the field in an unmanned location, and they can still meet their 5 nines and above requirements, even in the event of failure. As you come more into the center of the network, you can use some of the architectural nature of IP. I mean, after all, IP was built to be highly resilient. That was its purpose when it was first invented as ARPANET. So the network itself is incredibly resilient because it can find traffic across the network. So we can do non-redundant boxes. But if your customer still wants redundancy there, we support a whole range of redundant form factors as well. And of course, all of this network is automatically and automated by the Muse network controller. And as I mentioned on the previous slide, we support all of those transport protocols required, and we call that multi-stack MPLS. So one network element can support all of these different technologies using a different routing mechanism on each port if required, and being able to seamlessly switch between those routing technologies. We also support, interestingly, a technology that was built for 5G, but is finding more use in utilities, is this old idea of network slicing. When we move to our IT-OT convergence, some of the customers can be persuaded to put it on one network, but they're still concerned about the segregation between the IT network and the OT network with what is called hard slicing in 5G. When we position it to utilities, and when you position it to utilities, call it segregation, because then they don't get confused with 5G. But basically, you can segregate all of the IT traffic onto one slice of the network, and you can put all the OT traffic on a completely different slice, using a technology that guarantees segregation between those two slices. Then, of course, you can run the normal QoS and routing protocols in each individual slice on a slice-by-slice basis. Talk to us more about this if you're interested, because we do have a couple of live deployments using this. So just in summary, on the packet side, we have here the key values to take to the customers. We have two product portfolio ranges within Packet: XDR 2000 series, optimized for very high performance, very high throughput. The AR 1000 series, optimized for CI, because when you get to the medium and bigger boxes, they're fully redundant, fully modular, to meet those needs for the customers who want to be able to have that high availability in the network element itself. Our software is the same software across the whole of our portfolio, so they don't need to relearn. It makes learning much, much simpler. We support easy and simple handoff between the IP and optical layers with our coherent routing approach. I mentioned the multi-stack MPLS and the network segregation. The last thing to say here, we understand the network's not going to be one vendor. So we invest a lot of time, money, effort to prove our interoperability with all the other vendors for all of our various technologies. And one example of this is our investment in the interoperability showcase called ENTC, where we interop with all of the big packet transport vendors. Jonathan, do you want to say anything to the optical slide? No, I've dropped this on Jonathan. He might not even be here anymore.
No, I'm on the call. I can even turn my camera on. Thank you very much, everyone. Thank you, David, for all this great introduction. I think, as David mentioned, the optical part of our portfolio is essential for utility solutions just as much as the IP one is. And this just highlights a number of the kind of capabilities that we're bringing to the fore right now. When you look at the upper left, and I'll just go through these fairly quickly, we've introduced since the beginning of the year a new high-density platform. This is optimized for data center residency, which is an important and growing part of the market. It may not be there yet within the utility space, but it's good for you to know that we have it. So this uses front-to-back airflow, and it's meant for these kind of hot aisle, cold aisle environments. So actually, if you're running any data center kind of environments, be assured that we have this kind of technology available. We've also moving towards new higher rate transmission technology. This is based on very innovative 5 nanometer, 140 gigabaud silicon, which right now is actually the highest level achievable in the market. It gives you wavelengths up to 1.2 terabits per second for short haul, and really 800G, which can cover all sort of regional applications for over 1,000 kilometers, and 400G unlimited. So if you have very long stretches where you need to have higher bandwidth, this is something that we could accomplish. And we package this both within our new high density data center platforms, as well as within our traditional platforms that many of you may have and of course are familiar with right now. So we're continuing to ride the technology curve in terms of the latest transmission technologies. The important thing to understand, though, it's not always that you need the highest performance. In many cases, just the lower power, lower cost technologies are important. And we're continuing to ride those technology curves as well with the various 400G technologies, both in what you see here in terms of the CFP2 form factors, as well as on the left in the QSFP-DD transceiver form factors. So we can craft an optical solution on a transmission basis for you. Of course, if you need other types of interfaces besides gigabit Ethernet, such as a fiber channel, and to support, say, direct transmission of TDM interfaces, we have line cards that support that as well. In terms of your network, we support a very sophisticated OLS for carrying the wavelengths. This could be both ribbon wavelengths coming from our Apollo gear, as well as David mentioned, we support coherent routing or IP over DWDM in our NPT gear, and we support that through our optical line systems, as well as, of course, wavelengths from third parties. So this makes for a very open system that you can support any kind of optical technology on that. This comes, by the way, when you're looking at the overall package of optical, one of the things David had mentioned was understanding what's going on with your fiber. I don't show this on this slide, but we have very powerful OTDR capabilities that are able to monitor the health of the fiber and track that over time, that you can detect deteriorations before they take place. I think those are the keys. There's other things that we're talking about here that are probably a little bit less appropriate for the utility space, such as OTN switching, extension to L-band, and open control interfaces. But just to give you guys some insight into the breadth and sophistication of our Apollo portfolio. I'll hand it back to you, David.
Actually, Jonathan, I might get you to talk over the Muse as well whilst you're at it.
Sure.
The Muse actually is, for you guys, when you go to your customers, is really, really key value for us. I mentioned the three key values: MPLS-TP, legacy interfaces, PCM interfaces. Muse, I would say, with its ability to seamlessly manage both the packet and the optical network in a completely coherent way, I would say is the third, maybe even the most important value. So Jonathan.
Yeah, let me just say a few comments about Muse. So we decided to start making transition a few years ago from Lightsoft, which was our traditional network management system, but it was sort of getting long in the tooth. What we needed to do was move to a platform that was cloud native from the ground up, that could run in modern cloud native environments, as opposed to being tied to machines and certain kinds of operating systems, and also use the most modern techniques in terms of how code is developed using techniques such as microservices and containers for capabilities such as continuous evolution of the software itself. So some of the main features that we're highlighting over here is network automation. We have a very powerful workflow engine. What this enables you to do is actually automate it to your own pace. You could actually capture manual sequences that you are putting in to the Muse interfaces, and then convert those into automated workflows. So rather than needing to engage expensive professional services, this enables you to automate at your own pace. And it also comes with more sophisticated capabilities, such as being able to construct closed loop automation routines, all the way from service creation to downloading the appropriate parameters within the network itself, testing the new service, and then actually activating it, and ongoing monitoring of the service too. So it means that you'll have your operators will be more in the managerial role over the network rather than having to understand, all the details in terms of actually knowing every single specific detail. In terms of advanced analytics, we provide various powerful engines for network insights, network health. These are monitoring the capabilities of both the IP and the optical layer. As I mentioned before, things such as OTDR as part of the network health on the optical side. Of course, you also can monitor the actual performance of the optical signals too. So you have both the optical performance as well as the fiber health. And on the IP side, there's whole numbers of statistics that you can monitor in terms of the kinds of packet flows, the latency rates, and just understanding that you're kind of getting the service characteristics that you're expecting from your network. Muse understands that it's not living by itself. It needs to operate in a multi-vendor ecosystem. In some cases, this means interfacing northbound to various OSS and business systems. Maybe a little bit less so in the utility space, but you might have some of those systems out there, so we can support that through flexible northbound interfaces such as RESTconf APIs. And in some cases, you'll have other types of equipment in your network at the IP and the optical layer that you also want to integrate under Muse control, and we can support that through various southbound interfaces. A lot of these, by the way, you can build yourselves with low-code types of automation and service design tools that we make available to you. And then finally, as I mentioned before, it's a cloud-native architecture from the ground up. Totally modern in terms of the way this is constructed and the way this lives in your network, which is important because more and more these are the kinds of skill sets that people have in terms of deploying software, and some of the old skill sets based on the legacy kinds of what's called enterprise software are being lost. So you need to have a modern SDN type of control system that is cloud native. Back to you, David.
Thank you, Jonathan. So that's a rapid run through the capabilities. So what does Ribbon bring to you that you can take to your customers? Well, I would say it brings you the ability to give your customers the confidence that we're able to position a field proven, tailored, risk-free migration approach. So tailored, we're used to different operators needing different types of migration and support that, allowing them to migrate in their own time. In the mechanisms they want to. We have all the security that's required to put work into someone else's security ecosystem, and with our professional services, we can also recommend security components out there on the market. And probably not least, this solution has new features that are added to support critical infrastructure onto our modern products. So it's absolutely optimized for the need of critical infrastructure, and we've built a set of mission critical grade platforms. So you have a toolkit which allows your customers to feel confident, and that toolkit is proven reliability, secure, and can be tailored to meet their operational and business needs. So in short, we can provide you the proven local support, expertise, and experience that you need when you go in front of your customers. You can understand and rest assured that critical infrastructure is and will remain a key focus and investment for Ribbon across its portfolio. And as you see by the new features we add in every release. We have technology and continue to push technology that is specifically architected for mission critical fast communications, MPLS-TP being an example of that, and then the extensions that we're adding to MPLS-TP. As I mentioned, or Jonathan mentioned, the power of Muse should not be underestimated. It really does take network control, multi-layer network control to the next level. And it allows your operators to seamlessly add optical Ribbon's optical solution to only packet solution that's there today, if that's the case. Really easy to add the optical component
really, really easy to add and move to new telco if your operators so want to do that, because it has those capabilities that Jonathan very rapidly moved through. And then bringing that all together, we have this comprehensive toolkit, but we also have the ability to react to you and your customers' needs. The lines of communications are really, really short. So if you have issues, you can talk to us and you'll get an answer quickly. It won't always be yes, because we have to have the business on operational needs ourselves, but you'll get an answer and you'll know who to talk to. So we are able to give that sort of startup agility in dealing with you. And that sort of brings me to the end with this. So please, any questions?
Yeah, I have a question. It's Per here from Cyprus. If you look at the case when you look at to replace an SDH network with MPLS TP,
yeah,
how do you handle the timing and synchronization design, so to say, maybe interconnection with the old SDH network? I mean, do you need to plan for having external grandmaster clocks, for example? How do you monitor the performance of timing and synchronization? Is that part of Muse or?
So Muse at the moment is roadmap to bring the timing map into the feature set. I can't remember which release it is, but there's certainly a timing map will go in there. However, the timing requirements in critical infrastructures, while severe and probably not as severe as 5G, which our packet transport can meet. You know, if you're talking a few microseconds for 5G front haul, which we support. So using 1588 and various timing and synchronization to get to class D, C and D timing levels, we're confident the network can do that. But as you say, having a timing map showing the timing across the network is the next step where you can actually have a timing display. In addition to
if you, as a start, look at sort of transporting all the legacy protocols, analog protocols, using some sort of circuit emulation over MPLS TP, then
that's right.
Timing is not necessary at all, or you need at least some sort of design, some sort of setup of
the timing gets transported as part of the SES MPLS TP combo. So the timing is absolutely transported across that network. It's not like
you need some sort of design timing wise of the network similar to SDH, or
of course. I mean, all networks, all networks need design for the timing, because you can't route a timing. You know, if you're going to rely on the timing, you can't route it through 300 hops. So you have to design timing. You have to design timing and understand the route it's taking. Absolutely.
Okay. So the protocols you use then is SYNC-E and
SYNC-E and 1588. Yeah.
1588. Right. So do you need an external grandmaster for this, or is it built into the equipment?
We don't need an external grandmaster, because again, you've got to rely on the timing ability of the network to transport timing. A lot of the critical infrastructure, and especially defense, don't trust external grandmaster as in GNSS type receivers, because they say that can be just taken down anytime you want, and the network's still got to maintain sync. And bear in mind, these solutions also go to defense, so it's got to be able to keep the sync and timing across that network. I mean, for a deeper conversation around that, it's probably worth getting one of our technical guys to talk to you.
But I mean, if you look at the European utilities, what would they do typically? Would they put a cesium clock in, or would they use GNSS, or what the typical utility?
I'm not. Let us get back to you on that.
Can I hop in, David?
Yes, you can.
Yeah. So cesiums are pretty expensive things and pretty sensitive actually to use. So recently, what has become more popular are the rubidium clocks, which are, let's say, cheaper, and quite a lot of cheaper, and compounded with at least dual band GNSS. So you have GNSS receiver, which is dual band, that is keeping the rubidium basically,
the payload for a couple of weeks or something.
Yes, so primarily you say I don't need a stable source because rubidium is a class B it's a class B PRTC, so it's not the ePRTC but it's class B PRTC, so it's pretty much good enough. And then you compound it with GNSS, and then on the network you can use GNSS just to monitor whether you're drifting. So use GNSS as a monitoring reference. You don't use it to synchronization, and then you of course distribute sync with SyncKey plus PTP through the network.
You can use GNSS receivers around the network edge to monitor.
You use it only that you see whether you're drifting, So for example, I come from the mobile background more, not so much utility, but you would have a grandmaster at the end somewhere, and then it would have feed from the sync from the network, and then it would also have the GNSS, and GNSS is used only that you see whether you are okay or not. So you use GNSS more like a monitoring signal, and not you do not rely on it. That's the.
But you monitor this from the Neptune operating system, so to say.
No. This is if you have dedicated grandmaster somewhere.
Yeah, the grandmaster. But I've said if I understood it correctly, you use a dedicated grandmaster somewhere.
Yeah,
and then you put the timing signal out in the network, and then around the edge, maybe you want to monitor how it's going. Yes, I thought that basically at the edge that you use some GNSS receivers as well to compare against your SyncKey time, or
that's how you would do it in a mobile 5G operator, especially if you use a C-band, which is TDD, because when you get into TDD, then it gets complicated.
Yeah. So I mean, I think Per, that it's probably we should set up a separate call around sync. Specifically, we could spend an hour or two on it.
We can spend days on sync. It's an amazing topic that nobody knows much about, so it's really interesting.
Yeah, I'm sure we can do that with you guys on the particular projects we're working on. I was more interested in how much we need to prepare our customer for this, so to say, if they are aware of it or not. If they have a 30-year-old SDH network now, they don't know what a grandmaster is. So.
Of course.
But they know what the PRC is, but they do know what PRC is. Actually, people who have SDH legacy, they understand sync better than the IP people.
Yes.
Because IP people, they fucking don't have a clue. Sorry, David. They don't have a clue about synchronization. Sorry.
Yeah. But now they need to think about SyncKey and PTP, and that's new for them.
So I'm conscious that we've gone past the top of the hour. So if there's any other burning questions, if they're not, I'll stop the call at this point. But we can follow up. Any questions, Josh?
I put a question into the chat. Please, can we have some case studies?
Yeah, for sure.
Fantastic. Thank you.
Okay, so thank you very much for your time. I will send over some case studies, and Per, we may set up a call around the sync itself. It may even merit a small group where we can talk about sync. Okay, thank you ever so much, everybody, for joining. Feel free to contact myself or anyone else in Ribbon, and we'll be happy to go into more detail around each of these aspects. We are your support for this. We truly understand that you are the guys that help us win. So please talk to us so we can help you do that. Thank you ever so much for your time this morning, and have a great day.